Hi guys, good afternoon. So in the last session, we have seen version 2 policy-based site-to-site VPN between firewalls, and today we'll go with Flex VPN. Now, your Flex VPN, basically, this is going to combine all the different types of VPN. Okay, you can talk about your like site-to-site VPN we have studied, that technology, as well as you can talk about DM VPN. Okay, you can talk about a remote access VPN. Okay, and previously in Cisco itself, we were having something called as easy VPN, which was also known as EZVPN, like this, easy VPN. Okay, so all these technologies combined is what your Flex VPN, and it's basically based on your IKV2. Okay, so it solves many problems, right? So we'll see first of all what are the problems your Flex VPN solves. Okay. Now, let me open that book. The book I have already shared with you. Okay, on the drive. This is the book that I have shared. I might have already received it. Correct? Yeah. IKV to IPsec virtual private networks, and this also contains your Flex VPN. Okay, so see here. If we talk about Flex VPN is a robust standard-based VPN technology that enables large business to securely connect branch offices, and remote users. So remote user means remote access VPN, and branch offices is your site-to-site, okay, and multi-site concept. It provides significant cost saving compared to the cost of supporting multiple separate types of virtual private networks solutions like your GRE, crypto map, virtual tunnel interface-based solutions and all. Okay. So your Flex VPN relies on open standard-based IPv2. Your Flex VPN is based on IKV2 as a security technology and provides a number of Cisco-specific enhancements to provide high level of security, added value, and competitive differentiations. Okay, so it provides several benefits over the previous VPN technologies. Okay, now it is supported on Cisco ISR generation 2, okay, and all these ASR routers, iOS XE, CSR routers. So all these series it is supported, and Cisco AnyConnect is also supported as a link. Okay, so Cisco AnyConnect will come across when we study about SSL VPN. In the SSL, we will study about full client or thick client VPN. There it will be useful. Okay, now we know that over the years, Cisco IPsec VPN solutions have evolved from crypto maps to tunnel protections. Okay, like initially static crypto maps were there, then dynamic crypto maps were there. Then this easy VPN was there, which was based on crypto maps. Okay, then GRE came out with the crypto maps. GRE interface with tunnel protection came up. Then later on, IPsec VTAs came up, virtual tunnel interfaces, static and dynamic, right? Then after we studied DM VPN kind of concepts came up, and then your enhanced easy VPN with the IPsec VTA. So these all concepts came up. But the thing is, even after that, Gate VPN was there, correct? So because each solution serves different purpose, each VPN has a different purpose. In case of IKV1, what we saw is each VPN has a different purpose, correct? And those different features were developed relatively independently. That means each VPN technology has been developed independently, okay? Each with their own configuration constructs, show comments, okay, underlying interface infrastructure and feature sets while sharing the basic building blocks of ISACAMP and IPsec. What does it mean? Each VPN configuration has its own configuration commands, show commands, okay? Then how you configure it on the interface, as well as, they will use what in the basic building block means the basic configuration, what they were using, ISACamp and IPsec, correct? So an example of this divergence is the DMVPN predominantly uses multi-point GRE interfaces, supports DVTI also, dynamic virtual tunnel interface, okay? So it supports dynamic overlay routing. See, in DMVPN, we used EIGRP. In the MGRE, we had to manually give a static route, if you remember, correct? But DMVPN was supporting what? Dynamic routing. We use EIGRP. So it supports dynamic overlay routing, but it does not support what? AAA authentication. In DMVPN, we cannot configure what? AAA authentication. And also per user or per peer policy out of the box. That means they are also not supported. Then in the Cisco Easy VPN was there, which uses point-to-point IPsec VTA interfaces, also has AAA support, also support per user and per peer policy, but does not support dynamic routing. So that means one was having some benefit, another one was having the same thing as a disadvantage. Okay. So this was a problem. Now this separation and divergence have several drawbacks, notably in terms of learning curve. When you learn the technology, then it can create confusion, and then ease of troubleshooting due to various concepts and commands involved. So it is difficult to configure various IPsec VPN solutions on a single device. Now, because maybe in your organization, you might have a site-to-site VPN configured, or maybe you will require a DM VPN configuration, correct? And maybe there are remote clients who are working in your organization. So for them, you need a SSL or remote access VPN configuration, correct? So multiple different configurations are there, and it is difficult to configure the various IPsec VPN solution on a single device. Okay. So what IKV2 did, the IKV2 protocol brought together a lot of functionalities that were earlier defined in multiple different RFCs. The introduction of your IKV2 into Cisco IOS was used as an opportunity to unify the different VPN solutions, bringing all solutions under the same configuration and basic building blocks. That means one configuration for everything. And making available all the protocol functionalities and all features to all VPN technologies. So your Flex VPN, see IKV2 combines, yesterday also we saw, right? In the IKV2, we can decide. So your Flex VPN, what happens? That Flex VPN is a combination of your site-to-site DM VPN as well as remote access VPN also. It combines all the functionalities, all the protocol functionalities and features of all the VPN technologies. This resulted in what? Flex VPN. Clear? Now, with exception of Get VPN, because Get VPN is not really creating a VPN, but it provides encryption service to an existing layer 3 VPN. That means you already have a layer 3 connection, and to that, you just provide encryption, right? Phase 2 configurations we were downloading from the, you can say phase 2 configurations we were downloading from the server, key server, right? And this is basically used in the MPLS kind of environments, okay? So your Flex VPN encompasses all previous IPsec VPN functionality, and Flex VPN is supported by vastly improved framework based on IKV2 standard, point-to-point tunnel interface, and AAA. So this has combined all the protocols. So that means no, you can say drawback at all. Okay. And then this is building blocks, and there's something else that I need to explain here. Let's see VPN maintenance overhead. There's too much if you want to read. Configuration exchange routing. So in the building blocks, we basically have three. One is your IQuotient2, which it will be using in the backend. Then it will be using point-to-point tunnel interfaces. Okay. And see, normally tunnel interface means what? We say that tunnel interface means route-based VPN. Okay. So this will work as both. Okay. Whenever required, accordingly. Then after it is also integrating with the AAA infra. Okay. Then anything else? Let me see if I need to explain here. See, as per VPN introduction, this is sufficient that what is Flex VPN and why you use it. That we were having drawbacks in the previous technologies with the version 1, and there were separate technologies, and it is very difficult to configure all the different VPNs in one single device. So I version 2 with Flex VPN solves this problem. Okay. This problem we talked, right, that you have to use different commands, right? Yes. See here. Correct. Like here, what was happening, dynamic routing was not there in the easy VPN. It was there in the DM VPN. But in the DM VPN, we were not having AAA support. Easy VPN was having AAA support. So like some of the VPN technologies, they were having some drawbacks, but those drawbacks were not there in the IKV2. Why? Because your IKV2 brought together a lot of functionalities from all different VPN technologies, all the functions and features, they came under one single VPN technology. And that VPN technology is what your Flex VPN. Is that clear? Yes. And more, if you want to dig deeper, I have shared this book. You can check it out. Okay, so now let's see the lab, how your lab will be. The virtual tunnel interface, VTI, we know we have used in the GRE. Then we have used SVTI, correct? We have configured SVTI. Remember what is SVTI? Removing the GRE header. You are removing the GRE header. Then we have DVTI, Dynamic Virtual Template Tunnel Interface. Okay, where see, whenever we define a tunnel interface, what happens? That we always give a source to the tunnel and also destination to the tunnel. So if I give a destination, it becomes fixed, static. It becomes VTI. So if I will not define destination, that will become DVTI. We will not use GRE multipoint also. We will dedicatedly create a virtual tunnel template interface. DVTI, see here. Dynamic Virtual Tunnel Interface. Here we don't define a destination, right? That becomes DMVPN question 1. Right? See here. DVTI, Dynamic Virtual Tunnel Interface, can provide highly secure and scalable connectivity for remote access VPNs. Okay. So DVTIs, okay, this is talking about DVTI, which is Virtual Tunnel Interface. Let me show you about Dynamic Virtual Template Interface. Okay. See, this is, yeah. See here that the FTD version 6.7 introduced SVTA, which is supporting building which is having the support for building your route-based VPN, and which helps you to simplify configuration by not needing to manage complex access lists, correctly ordering the crypto maps. Okay, that means, see, whenever we use a route-based VPN, we don't require access lists, first thing. Okay, so in the SVTAs, we have certain limitations, like what? For large enterprise hub and spoke deployments, managing the VTA configuration of hundreds of SVTAs is challenging. Okay, that means manually configuring the virtual tunnel interfaces, okay, for hundreds of different deployments is complicated. Then adding a new spoke requires a new SVTA on the hub. Kind of what we have done on the hub, you have to, like, see, two mappings have to be done. Two mappings have to be done on the hub, also on the spoke. Then for spokes using a DHCP on the outside interface, the hub needs a configuration update every time the spoke's IP address changes. That means if the IP addresses of the spokes are dynamically changing in that case. Okay, so there are some limitations. So DVTI overcomes these limitations. Okay, using only one DVTI, that means, see, you don't need different tunnel interfaces for different destinations. Using one tunnel interface, I can communicate with multiple destinations. So using only one DVTI for hundreds of spoke instead of configuring one SPTI per spoke. Okay, requiring no additional VPN configuration when adding new spoke. I don't require any new configuration. Okay. Requiring no configuration update on the hub when the spoke's DHCP IP address changes. So we have certain benefits of the DVTI. And that's why here we will be using what? DVTI. Okay. So this we will be doing on the hub. On the hub, we will be configuring what? DVTI. Okay. Now let's go and open the lab. UND is down. And whenever you will configure a dynamic virtual template interface, so you will not configure an IP address. Okay, on a DVTI, you cannot configure an IP address here. Yeah, DVTI only in hub, then the spokes, if the spoke is there, in that case, it will be same like your normal configuration, like virtual tunnel interface. Static. You'll understand. Like that, spoke and hub. No, this is not that. Right now we are doing Flex VPN on the site to site. Okay. Like we are not going to create multiple destinations right now. But even if you create, doesn't matter. Okay. Same configuration will remain on the other spoke also. The same functionality like same functionality. But here we don't have to do any sort of manual mapping and all. That is not needed. Z0 by 0, and then this side Z0 by 1. Now this will be our ISP. This is, you can say like this is HQ, because same sort of things we have in the DMVPN kind of concept also. We have a HQ, we have branches, you call it hub and spoke also, correct? So right now I'm showing you according to one spoke. You can see the same thing for multiple spoke also. Okay. So this is the HQ, and let's say this is the site one. This is, let's see. So in here, we'll be using the network 11110 plus 24. Here we will be using 12110 plus 24. Here one loopback will be there, 10111 slash 24. Here we will have a loopback. The IP address here, 11111. This will be 1111. This will be 121110. And this one will be 12112. Okay. Start all the nodes. Now here, first of all, basic configuration. Basic configuration for HQ. OCM, let's say, HQ. Z0 by 0. Interface loopback one. One moment. Then we have site one. So we one one two. So we two dot. Let's done. This is the ASP. This will be 11 one 12 route is not required. This is the basic configuration done. Okay, and here we will use a tunnel interface also because we have to use DVTA, SVTA, right? So that's all. And now submit 1.0 flash 24. IP address at least on the other side we will require, right? On this side we will require. So that's all. On this side we will configure VTA only, right? That is the thing. This is our tunnel subnet. Okay. Now let's copy paste the configurations. This is HQ, site one, ASP. This is HQ. This is here. No. So public to public connectivity, let's test. We'll do thing 12.1 to connectivity is there. Now we will configure tunnel interfaces, right? So on the HQ, we will configure a DVTA, and here we will configure a VT. That is virtual tunnel interface. Okay. Now see how you configure DVTA. Configure DVTA on HQ and DVTA on site. Okay. Now, like I said, on DVTA interface, we cannot go and give the IP address. So if you want to assign an IP address to DVTA interface, so to a DVTA interface, you assign IP address by using some other interface IP. See here, if I show you. Let's see. Let's VPN configuration, change of projection. This is about VRF. Let's see here how you will configure. You will say interface virtual template and number you will give. After that, you will say type is what? Tunnel. And then this will use IP address using this command, IP unnumbered and the interface name. So you can give a physical interface or a loopback interface. Okay. So for this DVTA configuration itself, what we will do, we will create one more loopback on the hub only, on the HQ only. Okay. So first we will configure one loopback. Let's say here in our configuration, what we are using right now. Okay. Here we are using loopback 1. So we can configure loopback 0 or loopback 2 or any number as per your choice. Okay. So what you'll do, first of all, you will configure, you will say interface loopback 0, let's say. Okay. Then to this loopback interface, you will assign IP address. And now what is the IP address you want to assign on the this side? 1.1. 1.1 IP from the tunnel subnet here 1.1 and on the other side 1.2. Correct? 1.1 255 0. This is clear. Done. Okay. Exit from here. Now say interface. Give a question mark. Do you see a virtual template here? Right. So I'll say interface virtual template. Then we can give a number. So let's say number 1 I'm giving here. Then after I have to give what? Type. And what is the type? Tunnel. It's clear? This is done. All right. Now here, if you want to give an IP address, IP unnumbered. Okay, so if you want to assign V4 IP, if you want to assign V6, then IP V6 like this. So right now V4 we are using. So I'll say IP, then I will use the command unnumbered. Okay, enable IP processing without an explicit address. So I'll say IP unnumbered, unnumbered, then through which interface you want. So I want it from loopback 0. This is clear. Okay. Once this you have given, now a tunnel interface should have a source. So what we will say, tunnel source, and what is the source? Now again, you can give the IP address or the interface name. Okay. So either you can say Z0 by 0, that this is my tunnel source, my physical interface. No. Source of the tunnel interface is always your public IP. Public IP. Your tunnel source will always be your public IP. So either you can say Z0 by 0 or you can say LA1111. That is up to you. Okay. Like in the route-based VPN, we create interface tunnel 0. We say tunnel source. The same concept is here. But this time, understand this thing. See, let me show you the comments first. My DV, yes, see here. I'll say interface and what I said, virtual template 1. Okay, then I said type is tunnel. Correct. Now this is similar to your command. You say interface tunnel 1. After this, what we were saying, that first of all, tunnel source you used to give. You used to give what? Tunnel source. And then you used to say Z0 by 0, because this will be your public. So this is also tunnel interface only. So here also you'll say what? Tunnel source, and your tunnel source is what? 0 by 0. Now here we used to give what? Tunnel destination, because in this mandatory, or else you used to say like tunnel mode GRE multipoint. But right now we are going with the IPv2, right? So here, after that, once you give tunnel source and destination, what you used to give? IP address? No, we don't give anything, any destination. In the DVTA, there will be no destination. That is the benefit of DVTA. Dynamic. Okay. So here you are giving tunnel destination. Otherwise, it will not come up. Correct? So here we don't require tunnel destination. Once you give tunnel source and destination, after you used to give what? IP address. So here, how the IP address? Here on this DVTA, I cannot assign the IP address. Okay. If I want to assign IP address, I need to use the command IP unnumbered. Correct. That for which interface you want to use the IP. Okay. So let's say this 0 by 0 or loopback 0 interface. This is clear. So these two are similar only. This is VTA. This is DVTA. Is that clear? Okay. Now remove it. Yes, again, so IP interface and so loopback 0 and IP address. Yes. Can we assign that tunnel interface and that the source and destination before this? Which IP unnumbered? Yes, we can do that. Okay. So this is the tunnel source I have given, G0 by 0. Done. This is the configuration done here. Okay. Now if I check, do show IP interface brief. Do you see the loopback interface IP automatically coming on my virtual template interface? Yeah. Correct. Loopback 0 IP automatically coming here. And this is showing protocol what? Down. So it will show down only. Because for communication, it will create a third interface, third virtual interface in case of Flex VPN. Okay. It will create a virtual access interface. It will not use even this virtual template interface for communication. When it is communicating with one site, it will create virtual access 1. Same way when you have more than one site, it will start creating virtual access 1, 2, 3, 4, 5. That means the need for statically configuring anything gone. This tunnel interface will automatically take care of everything. Is that clear? Even behind this protocol is down that we are not having that. But in case of Flex VPN, this will be down only, DVTA case. Why? Because when DVTA wants to communicate with a particular site, it will create a third interface, which is virtual access. Dynamically, it will be. Yeah, dynamically it will do. Okay. So it will create virtual access interface. And that virtual access interface will have status also up, protocol also up. Because it's not even using this interface for communication. It will use that virtual access interface. But to create that virtual access interface, this is needed. Is that clear? Yeah. Okay. Now, this side we are done. Let's go on the site one side. Now here, normal configuration, interface, tunnel 1, tunnel source, Z0 by 0, tunnel destination, 11.1.1.1, IP address, then 192.168.1.2. Sorry, subnet mask. Okay, do show IP interface brief. My tunnel interface is up. Let me try to print. Do print 192.168.1.1. No need of source. No, let me repeat. It will show IP route. So it will not use, it will use tunnel interface only. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Some command I'm forgetting or what. Yeah, it's fine. We show the piece. Yes, I'm forgetting some command. Let me check. Configurations, we do DVK configuration. Loopback we have created. Virtual tunnel interface we have created. Routing protocol we will need when we want to communicate from loopback to loopback. Okay. Right now we don't need this. Then this is I quotient to configuration. This we will need when we want to provide the security. Okay. And this tunnel protection and all these things we will need later on. This is SVTA. On the other side, we configure tunnel interface. Everything is okay. Mhm. No, it's not. Gateway 168, 1.2. Let's look at the packets first. Capture Z0 by 0 interface. Are we getting anything here? No. Here we are not getting anything. What about ISP? Debug package. Wait a minute. I think I have pasted wrong configuration on the ISP or what? Or I haven't changed the host name only host name. No, sorry, yeah. Only host name was wrong. Now let me check again. Is it ISP also no problem? No, those are fine. Public to public communication we are having right. See what happens. Okay, might be we have to configure the VPN itself. Hmm. Let's try. Let's do one thing. We'll try for loopback to loopback communication. Okay. Yes, that means open protocols. So interface loopback 0. Then we say IP address and IP address is 192.168, 1.1, 255, 255, 255, Z. And this is on the HQ. IPN numbered the system. Yes. Let's configure AGRP also here. And router AGRP. Then no auto summary. Network 192.168.1.0 as well as network 10.1.1.0. Okay. Then we have site 1. Here we configure tunnel interface, tunnel 1, tunnel source, 11.1.1, sorry. Tunnel destination, 11.1.1. IP address, 1.2, 255, 255, 255, then router AGRP 10, no auto summary, network 2.2.0, as well as network 192.168.1.0. Figure AGRP and in the site 1, we configure AGRP. See, routes are received. We show IP route. Routed via routing information base. See, AGRP hello packets are coming here. Okay. These are going from 1.2 to 224.1.1 Okay, we have to configure the VPN on this. Okay, now understand the configuration. So we have configured the tunnel interface, right? Then we have configured the routing protocol also, correct? Right. Now, first thing you will do is you will configure what? I question to proposal. That's what we have been doing, like yesterday's configuration. If I show you yesterday's configuration for policy based and was configuration we do here. With that configuration, I think unencrypted should print, correct? That is what we are facing right now. wipe out. Let's try once VPN, and then if it doesn't happen, then we will wipe out. So that configuration will be ready. Okay. Yeah. This is GRE route based VPN I2 based. Now see here. How do we configure I2? First of all, we configure proposal, we configure policy, then we configure keyring. Now in the keyring, if you see here, that what was happening in the I2, I had to configure both local also, remote also. And then again, I had to say here that my authentication method is what? But this is eliminated. Here we just have to give local pre-shared key, and the command will be on the pre-shared key and whatever the key yourself. We don't have to give both the things local and remote. Okay. Then after we have to create I2 profile as it is. Okay. Then we will same way we will configure transform set, create the IPsec profile, and then apply that profile on terminal interface. Same features are there. Key is required only local. Yeah. That means I will have my key, you will have your key. That means this time key will be same. Yes, yes. That means this time we will automatically have the same key. So with the same key, we will communicate. Okay. We have the only local. Yeah, this thing only. This one. See here, if I show you the configuration. What is the key I'm using here? See, in the key ring, we are using the key Cisco. And same thing here, Cisco. So this time on both the sides, we are using the same key. So we don't need to define two types. And then we just use what? Authentication method. This is as it is. And here we have to define the template interface. Okay. Now see step by step, let's do the configurations. Keep it here on this side. Okay, see here now. First of all, we have done the loopback configuration. We have done the DVTI configuration. We have configured the routing protocol. Now let's start configuring phase 1 of I2. Okay, so first of all, we will create proposal. In the proposal, we have used SHA-1. Okay, so instead of SHA-1, if you want to use SHA-256, that is also fine. So let's go and type the comments one by one. I'll say crypto IKE V2. Then we will say proposal. So this is only tab will not work. Autocomplete will not work. Otherwise, command will work. So site 1 HQ both are same things. Crypto IKE V2 proposal and name it something like prop 1. Done. Now under the prop 1, we have to configure integrity, encryption, and DH group, right? Okay. These three things we have to configure. So we'll say that encryption I want to use is AES encryption, right? And the first one we will configure will be taken, right? So CBC 128. Then integrity. And integrity I want to configure is SHA-256. Group number 14 we will use. Here no like that. Okay. If you want to configure, like I said, if you do not configure integrity algorithm, PRF will give default. Okay. But if you have given, then you don't need to give PRF. Okay. Because automatically whatever we have configured will automatically become the PRF value. Okay. All right. Exit from here. This is done. Then after we configure what? I2 policy. So I'll say crypto IKV2 policy. And what is the policy name? Let's say policy 1. Done. Now policy must have the proposal. So whatever the proposal we created, that proposal we will call here. Okay. So we will say the proposal is what? Top one. This is done. Exit from here. 2 things done. Now third thing we configure is what? Your keyring. So we'll say crypto keyring. Yes. Question. IKE v2. Okay. Keyring and keyring name. Let's name it KR1. Okay. This is clear. Enter. Now under the keyring, what do we configure? We configure peer. Now what is the peer IP address? So in our case, it is 12.1.1.2. This is done. Then here we have to share what? Pre-shared key. So I'll say pre-shared key. And this time I will not define local or remote. I can define directly my pre-shared key here. Okay. So you can say 0 also, that is also totally fine. And system. Then that means you are directly typing. So this is also unencrypted. This is also unencrypted. Same things. No, not secure. 6 is secure. If you directly type or if you give 0, it is unencrypted. No, that is totally fine. Yeah, that means here in the peer also I can give the name or address. This address will be also taken as an identity only. Yesterday I also said the same thing. Okay. Done. Now we can define what? Address. So I can say address is what? My public peer. Okay. This is done. Then we have to give. See here. Peer R3. So here you can either give the name, either give the IP address, both are fine. Up to you. Okay. So this will be taken as a name only. Actual address is this one. Here what I have configured right now. This is clear? Okay. No, like I said, yesterday I also said the same thing, that you can configure both the things. No, it will be needed. It will be needed. That will be needed because here, see here, when I say peer and if I give question mark, what it says? Name of the peer block. What is the name you want to use? Okay. This is done. So exit from the peer settings and exit from here. This is done. Then after we will create what? IKv2 profile. Okay. 3 things are there: proposal, policy, and profile. Okay. No, starting from the P order, you can remember proposal, policy, and profile. Okay. You can say crypto, IKv2, then you can say profile, and let's name profile 1. This is our one profile. Now here, local and remote authentication method we have to give. Okay. So I'll say that authentication, okay, local, and what is the method you are using? Reshare. Okay, this is done. Same way, remote. Okay, done. Then match the identity because it is also saying what? Match identity. Okay, and identity you want to match is remote. What is the address? Now remote address is 12.1.1.2. This is done. Anything remaining? We have to attach keyring. Okay, we have to attach what? Keyring, and also we will specify the tunnel interface for dynamic interface creation. So the virtual access interface will be created through which interface? This one. Okay. So I'll say keyring, and keyring name is what? KR1. local, and name of the keyring is AR1. Then after we have the interface virtual template and number is 1. Now either you can give enter here or else you can also specify that mode you want to use what? Auto. So auto means enable auto feature on the I profile. Okay, so you can do that. So you can say mode auto, or if you don't give, both are auto only. Okay. Let's say I'm using here mode auto. Is that clear? So this will see, it says what? Mode auto takes precedence over the configured. So if you have configured, right now I have given that virtual template interface number is 1 and the virtual interfaces will be created automatically. Okay, so you can say auto, or if you want, you can configure also. Okay, that is fine. Is that clear? Okay, then this is done. Then after next we have phase 2 configuration. This is so far this is phase 1 configuration. Next is what? Just create your IPsec transform set. With to IPsec transform set pset ESP AES ESP SHA. Okay. This is done. Once this is done, crypto IPsec profile. Let's name this profile as VPN profile, what we usually name. Okay, then IPsec Isaac. Okay, no. Then here we have to give set the transform set. Name is what? Pset, and also set the IKv2 profile. IKv2 profile, and name of the IKv2 profile is profile 1. This is done. Then last step, we will apply it to the virtual tunnel interface. Okay, so I'll say interface virtual template 1. Then tunnel protection IPsec profile, and name is what? VPN. This is done. SVTL we will configure it later on. You can see ISACamp is on. Okay. Now let's go to site 1. Okay, note down all these configurations. Which one? That is SVTA. That is to remove the GRE header. Later on we can use. So in this one configuration, your DVTA, SVTA, and VTA, all 3 things are used. Okay. Okay, so here we configured. Okay, let me make changes here itself. In this only we will make changes what we have done. This is integrity SHA 256. This is correct. DH group is 14. Yes, is correct. CBC will come in between. CBC will come in between. This is AR1. AR11. And you can give their IP address or name of the this also. So this IKv2 profile name is not drop one, profile one. R112 remote address. Key ring is AR1. And this one we have set mode auto. These two is configured with correctly, not correctly. AES we have used. We have used here. Then we have created IPsec profile, which is profile. Transform set is okay. One. So this is what we have configured. Yeah. This will be VPN profile. Yeah. No. See here. I question to profile. Okay. So this is the configuration. Then this is site one configuration. In the site one also, we will make some modifications. Here, peers will change. Site one. So here, first of all, we don't require DVTA. So this will be removed. AJP we have configured, right? See here. I think I have. Let's take 2 times here. So here, what will be the changes? Charter 56, AES, CBC, group number 14, policy name, proposal, peer address. And here, peer address will change. Then anything else. Key will be same, so we don't have to change the key. The rest everything no change. Okay. So and apply this configuration. Well, somewhere name mistake. Mhm. Where is the error? Okay. Yeah. The virtual template interface is not there, right? Here, this configuration will not come in place of this interface tunnel one. Once the temp is on, tunnel interface came up, AGRP also came up. So it was VPN on. Okay, that's why we were not having tunnel interface communication. And here we can see, right? And here also AGRP neighbors came up. Do show IP route. So we can see we have the route for 10.2.2.2. Now I can see looping 10.2. So now you can see we have tunnel established. So if you say do show IP interface brief, do you see this one extra interface created automatically? Virtual access one. So this is the IP address. So it will use, see, we have a loopback interface. Your DVTA interface will use loopback IP, and your virtual access will also use this IP. This will happen. Now, what will happen if you will add one more site, and there also you will do this sort of site to configuration. Okay, let me close it. This is not. If you will remove the loopback 0, then IP is gone. No IP address. Because if loopback is gone, your DVTA IP will be gone. If DVTA IP is gone, virtual access IP is gone. Tunnel down. Okay. This will never come up. This will show you down only. Okay. So now if you see, let's say I have one more site. I have another site. So what I can do, I can use here like my tunnel. This is site one. So whenever I'm using this, in place of these addresses, remote addresses, I can make it 0, 0. I can make these addresses 0, 0. Multi-site. Then it will start creating, if I have another site, it will start creating virtual access 2, 3, 4, 5 like that. So see here, let's say for example, I can make this one also 0, 0 because this time we are not downloading anything, right? We are not downloading anything. Here we don't have that you have to download any NHRP mapping or so. We don't have that concept here. Is that clear? Hmm? Everywhere you can make 0, 0. You can try this. So if everything is 0, 0, then somebody has to communicate, right? Somebody has to communicate. So this is the reason that here we will give for HQ IPs. Now every site will have HQ IP. So HQ will do what? HQ will just use this IP address. That means this is the virtual template interface, and using this for site one, it created virtual access 1, then virtual access 2, virtual access 3. So this thing in your book, it is mentioned. About the virtual access. See here, the Flex VPN supports automatic detection of tunnel encapsulation mode and transport IP protocol type 1 responders, such as Flex VPN server, that enables them to support initiators using multiple encapsulation mode and transport IP types. So here what will happen? Basically that it will create what? It will create a multiple your virtual access interfaces. Okay, like here it also says that the auto detect mode is configured in the IQVP profile that overrides the configuration obtained from your virtual template. And the cloned virtual access interface instead derives the encapsulation mode and transport IP type from the incoming IPsec security association protocol. So that means whatever the tunnel negotiations are coming, automatically it will create the tunnels. Okay. And see, this is what we have configured in the IQ2 profile, virtual template 1 mode, auto.
Now the possibility. We can run another router with ISP and configure this.
Same thing you can configure.
Then the communication between the back to the ISP and the third.
Yes, it will happen. Okay. So you can try it as a task. Right? Just add one more router. Right now I have site 1 only, you add one more site. And there also you do the same configuration, whatever you did here. And in the HQ, make the clear IP addresses 0, 0. That's it. Because here right now, this is single site to site. So in the HQ also, I have configured that what is my clear. Correct? So change this thing and try.
Only in IPv
On
IP with 0 and site again.
Yeah, you have to manually give.
Okay,
so try this.
Not consider the same IP address with 2 times.
No, same IP address 2 times IP conflict. Okay. Otherwise, you will have to go with the overlapping concept. Translation also you'll have to do that. If like you have another site where also inside you have the same subnet, then overlapping you have to do.
Yeah.
Okay. First do this. Okay. All right. Online people here. So this is the notepad for your Flex VPN. Both are issued. Flex VPN and policy based, right? Route based is shared. Okay. All right, guys. Then now next thing we have in our VPN topics, we will start with the SSL VPN. Your site-to-site VPNs are done. Now we'll go with remote access.
You're not using VPN with
Hmm?
You're not using VPN with
You can configure same thing.
different in
How different? See, where we configured. This is yesterday we configured, right? Policy based. IQ2 policy, encryption, integrity, these things you will configure. This is not 2 times, this is only 1 time. Just keyring, you configure it as a tunnel group. Other than that, see here, IQ2 proposal, the same things we say, integrity. This is the phase 2, transform set. Okay. Now, in the last, what we were doing, we were defining 2 keys. This time you will define only 1 key. This is the change you will have to do. That here you define 1 key. Okay. So similar kind of concept is there. And nowadays we are using next generation firewalls, so you just have to click with this. Okay. So these 2 notepads I have shared in your drive. Now there is one more task. This is it, but for tomorrow you have to search few things. What you have to search is see what you have to search. What is SSL? What is SSL VPN? SSL handshake. What is SSL? Client plus VPN. What is SSL? Client VPN. Client or full client. These things you have to search. Client less VPN. Let me check what all the topics are left. So up till here we are done. These are the many. SSL clientless, full client, CA based, L2. So tomorrow we'll go with the SSL theory. Then one day, one practical. I think next week will be done. Yeah, like we have around 6 sessions to complete these parts. Okay. Clear? Okay, guys, then I'll see you tomorrow.